All right, so 3.1 quadratic functions. The graph of your quadratic function would create a parabola in which you have generally you have two types of parabola. It can either concave up or concave down. Concave up will create the U shape. Concave down is just the upside down U. Notice your vertex on concave up will be your lowest point of your graph. Vertex on concave down will be your highest point of your graph. Coordinates of your vertex will be considered HK. Now, when we're dealing with the center, coordinates of our center with HK, coordinates of our vertex is also HK. All right, so okay, look. All right, so standard form of a quadratic equation. F of x is equal to a times x minus hk plus k, x minus h squared, excuse me, x minus h squared plus k. Of course, a cannot be equal to 0, or if a was equal to 0, that will cancel out this whole quantity right here. So a cannot be equal to 0. But notice if a is greater than 0, in other words, positive, then your parabola is concave up, or in other words, opens up. If a is negative, then that means your parabola will be concave down, or in other words, open down. All right. So graphing quadratic functions with the standard, with your equation in standard form. So a couple things you can do to help yourself to be able to create a rough sketch of your parabola. And the more points and everything, more information you have, the more accurate your sketch would be. So first thing you want to determine concavity. You're talking about, is A positive or negative? Then we'll be able to determine our vertex, find x-intercepts, if any, find y-intercepts, then step 5, we would plot the points from 2 through 4, the vertex, x-intercepts, y-intercepts, and then any additional points as necessary. So basically, the more points you plot, the more accurate you will be. So if you want to create more points, create more accuracy, then you would choose more values for x, plug them in, find the corresponding y values. Once again, the more points you have, the more accurate your sketch will be. All right, any problems? Okay, so let's look at the first one. It asks us to graph f of x is equal to negative 2 times x minus 3 squared plus 8. All right, so first thing we're gonna do, like I said, is to determine concavity. So A is negative 2, so that means it's gonna open down. Next, we want to determine our vertex. And so going back to our formula, standard form, h and k are right here. That will be the x and y coordinate of our vertex. So we have to be careful here and look at our signs. So we're going to take the opposite sign of h, and then when it comes to k, we're going to use the sign that we see. All right, so if we go back to our formula and what it told us, we're right here. This gives us hk. So we use an opposite sign of k because that's x minus h. I say opposite side of k. Opposite sign of h because that's x minus h here. And then we're going to use the exact sign that we see for k. All right, so we have x minus 3, so we use positive 3. And then positive 8 is what we have here. So because of this minus sign, we use the opposite sign of 3, and then we use the positive 8. Any problems? So for number 3, we find our x-intercepts. Remember, if you want to find your x-intercept, you got to start off by letting y be equal to 0. So y and f of x are interchangeable. So we let f of x be equal to 0 and solve for x. So we subtract 8 from both sides and divide by -2, and that gives us this. So right here, that'll give us 4 equal to x minus 3 squared. All right, so now we're going to take the square root of both sides to get a square off. And don't forget the square root property. Whenever you take the square root of both sides, on the opposite side of your cancellation, you have to do plus or minus. So that's plus or minus square root of 4 equal to x minus 3. That leaves us with this. So we're plus or minus 2 equal to x minus 3. Now to solve for x, we will add 3 to both sides. Then that will give us this, x equal to 3 plus or minus 2. Now because we can add and subtract 2 from each other, add and subtract 3 from 2 from each other, then we can go ahead and do that. 3 plus 2 is 5. 3 minus 2 is 1. So don't forget they were x-intercepts. So the ordered pair is 5, 0, and then 1, 0. So you have 2 points that were created. All right. Any questions?
You start right here so I can write it down right quick.
Mm-hmm.
Okay, I got it.
All right, sounds good. Thank you. All right, so next one we want to find a y-intercept. And to find the y-intercept, you let x be equal to 0. So you plug 0 into your equation for x. So that's negative 2 times 0 minus 3 squared plus 9, plus 8, excuse me. Then negative 3 squared is 9. Negative 2 times 9 is negative 18. Negative 18 plus 8 is negative 10. So that would be your ordered pair, 0, negative 10. Any questions? Any questions? So then you go ahead and graph that rough sketch, those points that you have. And it will look something like that. Notice I graph my two x-intercepts, my vertex, and the y-intercept. And once again, the more points you decide to plug in for x to find a corresponding y value, the more accurate, this whole graph would be. Excuse me. All right. Any questions? Any questions? Let's scroll up. All right. Vertex of a parabola whose equation is f of x equal to ax squared plus bx plus c. So it's not in that standard form that we were mentioning earlier.
I'm sorry, can you scroll up a little bit?
How far you need?
Okay.
Okay.
Okay, that's good. Thank you.
Yep, not a problem. All right, so here our equation is in this form. As a matter of fact, that's the form we normally use to see in our quadratic equations. So we can get our coordinates of our vertex by first doing negative b over 2a. And then we can take that negative b over 2a and plug it into the formula. Whatever that number is, plug it into the formula, and then that will give us the k for our vertex. All right. So first one here, f of x is equal to negative x squared minus 2x plus 1. So we want to graph this one. First thing we do is just flow with the same steps that we had before. We look at a. A is equal to negative 1, so that means it's going to open down for us. Remember, it's just positive, it will open upward. Then we need to find the coordinates of our vertex. So to find h, that's going to be negative b over 2a. And I pointed out right here, make sure you don't lose a negative. There's a minus sign in the formula in front of that b, and we're plugging in negative 2. So that should be negative 2 over 2 times negative 1. So that's 2 over -2, which is -1. All right, now take -1, plug it into your function to find k. So remember our function is -x² minus 2x plus 1. Take that -1, plug it into the function where you see x. So it's negative times -1² minus 2 times -1 plus 1. Do the math, you should get 2. So it just makes our vertex -1, 2. All right. Step 3, find your x-intercept. Let y be equal to 0. So that's what we did here. -x² minus 2x plus 1 equal to 0. And since I can't factor this equation right here, I can use the quadratic formula in order to find my two values for x, two solutions. So I use -b plus or minus square root of b² minus 4ac over 2a, plug in accordingly. So we see right here, a is -1, b is -2, and c is 1. And so I plug those values in right here. And simplify. Try to move up too quickly. Give you guys a chance.
I'm sorry, I couldn't copy it.
Which part?
Right there. Thank you.
Right. Yep, not a problem. Just let me know. All right. So simplifying, we'll have 2 plus or minus square root of 8 over -2. We have right here. We can actually simplify that further. So I just went ahead and turned those into decimals. I knew that it wouldn't reduce to solid integers because remember we have to graph it, so we need a decimal value, some type of numerical value, so that we can graph. So that would be negative 2.40 and then 0.40. All right, are you okay? All right, so plugging in 0 for x. F of 0 is going to be negative 0 squared minus 2 times 0 plus 1. Simplify that, and you'll have 1 as a result. So that's going to be 0, 1 for that ordered pair. All right, once you have your y-intercept, you can go ahead and graph, and those are your 4 points. All right, any questions? Any questions? All right, let's scroll up. All right, the next thing that they point out in this section, if a is greater than 0, and we already mentioned this before. In other words, if it opens up, you're going to have a minimum. And so it's just connecting the fact that the negative b over 2a is going to be the x component of your minimum. And then if it opened downward, then that negative b over 2a will be the x component of your maximum. All right. So using that information says consider f of x is equal to negative 3x squared plus 6x minus 13. Determine whether it has a minimum or maximum. So first thing we recognize that a is equal to -3. Remember, a is going to be what's sitting in front of x squared. So a is equal to -3, so it means it opens it down, and that means you're going to have a maximum.
Can you go back a little bit?
How far?
Right there. Thank you.
Mm-hmm.
All right. That's good. Thank you.
Okay, not a problem. All right, so B, find the minimum or maximum. Basically, it's asking you or telling you to find your vertex. So A is -3, B is 6. So you take 6, plug it in for B, -3, plug it in for A. Excuse me. So that's -6 over 2 times -3, which is -6. So that gives you +1 for the x component of your vertex. All right, so now you take 1 to find K. You take that 1, plug it into your function. Doing that, we have -3 times 1 squared plus 6 times 1 minus 13. Ends up giving us -10 as a result. All right, any questions? And don't forget, this is the maximum. This vertex is the maximum because A was negative. Makes it up and downward. Any problems before we go to C? Make sure we're okay. All right. So next thing we want to do is identify the domain and range. And let me erase this. I'll put it back in a second. Let's do it like this. All right, so they tell us to identify the domain and range. And when you look at just a very rough sketch of our parabola, our maximum value is 1, -10. Probably shouldn't put this up here. See if I can. There's a way to do that. I don't have it. I don't worry about it. All right. So now if you want to look at your domain goes from left to right. Those are your x values. All right. And your range are up and down, which are your y values. So that's going to determine how you establish what your interval would be for each one. So now when you're talking about going from left to right, you know, this parabola, as it goes down, is going to continue to get wider and wider and wider. Nothing is stopping it from getting infinitely wide. So that means our domain, if I can get there, is going to be negative infinity to positive infinity. So that will always be the case for your parabola. Your domain should be negative infinity to positive infinity. And remember, those are x values that you can plug in. There's no x value that you cannot plug in for the domain. Now for the range, that will be determined or will depend on, first of all, if it opens upward or downward, and where your vertex lies. So if you look at our range, is going to go from negative infinity up to -10. And we get that -10 from the y component of our vertex. All right. Notice I use a bracket on that -10. Make sure you do that as well. And then this right here, I was just saying that if it was a, if it opened upward, then my range would go from negative infinity to -10 to positive infinity. So that's all I was saying right there is if it opened upward. If it was concave up, then your range would be -10 to positive infinity, but your domain would still be the same. All right, questions? Any questions? All right, everybody good? Everybody straight? All right, so that's it for 3.1. I know we got some time left, but I'm going to pause right here. Went to the dentist this morning, so trying to limit how much I talked today. So we got one in, so that was good. Anything else before we dismiss on today? Once again, if you have any requests as far as extensions or something like that, feel free to shoot that email to me so we can discuss a plan and make sure you guys get caught up. Outside of that, I will see you guys on Wednesday.
Mr. Tucker.
Yep.
Can I stay back after class and talk to you real quick?
Yep.
Sure.
Thank you.
All
Have a
right.
nice
Thank
day.
you. You have a good one.
Bye. Have a good day.
Have a great day.
All right. Y'all take care.
Mm.